Good morning, friends. In my last video, I explained you hybridization, that is sp, sp2 and the sp3 hybridization. Today I will take up hybridization of the carbon. That is, carbon shows a very unique property. It forms the saturated hydrocarbons and the unsaturated hydrocarbons. In sp3 hybridization, in my last video, I explained you taking the example of the methane, that is CH4. Now today, I will explain you how the hybridization of the carbon takes place in saturated and the unsaturated hydrocarbons. That is how we can define the double bond and the triple bond. First, I will take the example of the ethane, that is sp3 hybridization. If we see, there are 4 electrons in the outermost orbit of the carbon, 2s2, 2p2. In excited state, one of the electrons from the 2s is promoted to the 2p. Now, all the 4 electrons, they hybridized and form the 4 hybridized orbitals of the equal energy. Now see how the ethane formation takes place. See, as all the 4 orbitals are having the same energy, so one orbital hybridized one carbon overlap the hybridized orbital of the other carbon, forming a sigma bond. It is a axial hybridization, that is head to head. And the 3 hybridized orbitals, they form the sigma bond with 3 carbon atoms. So this is the sp3 hybridization, means 1s and p3. They hybridize and form the 4 orbitals of the same energy. In this case, the bond length of the carbon is 154 picometer, while the carbon hydrogen bond length is 109 picometer. Now in the case of the sp2 hybridization and the sp hybridization, these are the important ones. In the case of the sp2 hybridization, if we take example of the ethylene, that is ethene, CH2, and there is a double bond between the carbon and the carbon. Here, if you see the excited state of the carbon, one electron from the 2s goes to the 2p, that is vacant orbital. Now in this case, 1s and the 2p, they hybridized. 1s and the 2p, that is x and y, they hybridized, and one remained unhybridized, that is 1s and the p2. Here the character of the hybridized orbital is 1/3s and the 2/3 of the p, and it forms a trigonal hybridization. Now here 3 hybridized orbital and 1 is unhybridized. Now see here, in the case of the ethane, 3 hybridized orbitals, one of the hybridized orbital of one carbon atom overlap the other hybridized orbital of the other carbon to form the sigma bond, that is axial or head-to-head overlap, and the two hybridized orbitals, they overlap with the 1s of the hydrogen on both the carbon atoms, and they form the three sigma bonds. Now, what happened to the unhybridized orbital? This unhybridized orbital of both the carbon atoms lobes, they overlap laterally, that is sidewise. In my last video, I explained the pi bond where the overlapping takes place laterally or sidewise. So here, unhybridized, that is PZ, form the pi bond by overlapping the lobes of the unhybridized electron by overlapping laterally and form the pi bonds on both sides. Here important thing is that, electrons moving in the cloud, that is a space. So here we say that the clouds, they overlap laterally and form a shape like harpoon, that is above and the below of the sigma bond. So here overlap sidewise, pi bond, two equal electron clouds above and below form, and the important is that the direction of this pi bond, or we say it is always perpendicular to the axial or the sigma bond. Now here double bond is formed by one sigma and the one pi bond. Now here bond length between the carbon-carbon is 134 picometer and the bond length carbon-hydrogen is 110 picometer and the angle hydrogen-carbon-hydrogen is 117.6. So this is how the double bond between the carbon-carbon is formed. So one sigma and one pi bond. Now in the case of the sp hybridization, if we take the example of the ethyne or the acetylene, where a triple bond is between carbon and carbon atom. Here we see the excited state, one electron from the 2s promoted to the 2p. But here in the case of the sp hybridization, 1s and the 1p hybridized orbital, they hybridized and form the two equal energy hybridized orbitals, and the two remain as unhybridized. Now as the two orbitals, they hybridize, so character of S and P will be 50%. Now in this case, one hybridized orbital of one carbon atom overlaps the hybridized orbital of the other carbon atom to form a sigma bond. Here overlap is axially, and the other hybridized orbital form a sigma bond with the 1s of the hydrogen atom. Now what happened to the two unhybridized orbitals? See, two unhybridized orbitals, they overlap of the two different carbon atoms laterally or the sidewise to form the pi bond. Here one thing I explained to you, in the case of the sp2 hybridization, this cloud is just like this. See here, it is just like this, that is the below and above the sigma bond. Now when two clouds, that is in the case of the sp hybridization, if one cloud, that is this cloud of the unhybridized orbital, is one above and the other is below, then second lobe will be in front and the back. that is a form of the role upon the sigma bond. This is very important thing. Listen again. So here, two roles of the unhybridized, they form the pi bond below and above and the front and the back of the sigma bond. Here, three bonds are formed, that is carbon-carbon three bond, where one is sigma and two the pi bond. So here carbon-carbon bond length is 120 picometer and the carbon-hydrogen bond length is 106 picometer and the hydrogen-carbon-carbon angle is 180 degree. So this is all about how the hybridization takes place in the case of the unsaturated hydrocarbons. By taking example of the theme and the time, I think it is clear to you. If you like my videos, please share and subscribe. Thanks very much.